part 2 of the video for 3-3 polynomial identities. And now we're going to start looking at how to expand binomials that have exponents that are bigger than 2. So first thing we're going to look at is x plus y to the third and then x plus y to the fourth. So starting with x plus y to the third, that is the same thing as x plus y times x plus y, the quantity squared. And according to our sum of squares, x plus y, the quantity squared, is x squared plus 2xy plus y squared. And then we have to go through and multiply these together, and then we'll simplify our answer. So we have x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. Go through and combine your like terms. I have x cubed plus, I have 2x squared y and 1x squared y, so that's going to be 3x squared y. I have xy squared and 2xy squared, so that's another 3, and then xy squared, and then plus y cubed. So that is my solution for x plus y, the quantity cubed. Now we're going to take that further, and we are going to find x plus y to the fourth power. So I'm going to take an x plus y and multiply it by what I had in my previous answer. And I know this does get somewhat extensive whenever you're going through and doing it, but you're going to multiply the x by every term and then the y by every term, and then we're going to go through and combine like terms together. So we have here x to the fourth plus 3x cubed y plus 3x squared y squared plus xy cubed. Then I multiply the y, so plus x cubed y plus 3x squared y squared plus 3xy cubed, and then plus y to the fourth power. Give myself some more page here so we can look at this. And then we combine like terms. Well, there's only one x to the fourth term. And it's always a good idea. Typically, we start with what letter comes first alphabetically, and then list those in decreasing exponent form. And that'll make more sense as we move through this video with this lesson. So we have a 3x cubed y and a 1x cubed y. So that's going to be 4x cubed y. And I am going to go through and cross out the ones as I use them, so I can keep track of what I've used and what I have not. So next would be my x squared y squared. So there's a 3x squared y squared and a 3x squared y squared. So that's 6x squared y squared. Then I have my xy cubed. Well, there's a 1xy cubed and a 3xy cubed. So that's 4xy cubed. And then lastly, I have my y to the fourth power. So this is x plus y to the fourth is this big long thing here. Now, I don't know if you notice, especially if you did the beginning activity where you were looking at a pattern happening here. But if we look at coefficients, this is 1, 3, 3, 1. This one is 1, 4, 6, 4, 1. And that should look familiar because those coefficients actually follow Pascal's triangle. Anytime you were expanding a binomial, moving up in exponent, you were going to use the appropriate row in Pascal's triangle to get the coefficients that go in front. Now, these ones are a little bit easier because your x's and y's have coefficients of 1. So you don't have to worry as much about what those other numbers are, and I'll show you a little bit later on how to do the expansion whenever your numbers are not 1s there. So again, the coefficients, anytime you have an x plus y to the n power, you're going to look at the array known as Pascal's triangle. And again, that's your triangular pattern of numbers, where each number is the sum of the two numbers diagonally above it. So here's Pascal's triangle. You can see row 0, that's our 1. X plus y to the 0 power, row 1 is 1 and 1. You can see how that corresponds. That's x plus y to the first, then x plus y to the second, x plus y to the third, x plus y to the fourth. And then part B is going to ask us to expand x plus y to the 5th power. So we actually have to go through and find the 5th row of numbers, and then we are going to use this. Notice that the exponents of x are decreasing. So in row 4, it starts off x to the 4th, and then x to the 3rd, x squared, x, and then no x at all, because that's actually x to the 0. And then the y's go up. So the y's start at 0, and then go up to y to the 1st, y to the 2nd, y to the 3rd, y to the 4th. And that's always going to happen. That's actually going to be part of the binomial theorem, which we're going to look at next. So this is 1, 5, 10, 10, 5, 1. On odd rows, you are not going to have a solitary number in the middle. That number is actually going to repeat. Because again, this is row 5 here. So if we are expanding this, I am using row 5. So I'm going to start off with my 1. And that is going to be x to whatever power the binomial is. There's no y with that one. Then I use the next number, which is a 5. X goes down by 1 exponent, y goes up by 1 exponent. Then I use the next number. X goes down, y goes up. Then we use the next number. X goes down, y goes up. Then the next number. X goes down, y goes up. And then finally the last number, x goes down, and it's actually gone because there's nothing left. And the y goes up to its last one, which should match whatever you have at the beginning. So that would be your solution. That's your expansion. Again, this expansion, this simplified version only works whenever you have a binomial where both of the coefficients are 1. If they are not 1, then you have to use the binomial theorem, which is coming up next. This looks a whole lot more difficult than it actually is. This is where A and B can be any possible A and B. Notice you are still, A does start at whatever n is, and goes down by 1, and then another 1, another 1 until it's gone. And then the B term starts off not being there, and then it goes up by 1, up by another 1, up by another 1. And then your C's are going to come from Pascal's triangle. So you're going to use whatever row n is. So if n is 7, you're going to use the 7th row of Pascal's triangle. Now keep in mind, we do start at row 0. So the top one, you don't really use that. The 1, 1 row, that's technically row 1. So this is your formula. This is your binomial theorem. And we are going to use this to go through and expand 2 different binomials. This will require you to multiply. This is also how you can deal whenever you have negatives in your binomial. So if you have one of your terms inside your set of parentheses has a subtraction with it, you can use that as well. Okay, so we have example 5, use the binomial theorem to expand these expressions. We are going to find first x minus 3 to the 4th power, and then s squared plus 3 to the 5th power. So we do need to know which row we're going to be using from Pascal's triangle. Row 4 for this one is 1, 4, 6, 4, 1. And then row 5 is 1, 5, 10, 10, 5, 1. So that you know which rows you're actually going to be using whenever you go through and do these. I'm just going to throw a line in here to kind of keep my work separated. Okay, so This first one, my A is going to equal X. My B, I do have to put the negative with that. The formula, using the binomial theorem, is going to be my first coefficient, and then A to the fourth. That is a 0 there, not a 6. And then I have my next coefficient. A goes down by 1, B goes up by 1. Then my next coefficient, A goes down by 1, B goes up by 1. My next coefficient, A goes down by 1, B goes up by 1. And then my last coefficient, A goes down by 1 and is gone. And then B goes up by 1. And then I just plug in my A's, plug in my B's, plug in my C's. My C's are going to be whatever number. So this is C0, that's C1, C2, C3, and C4. So I have 1, and then times x to the fourth power. Then I have a 4, I have an x to the third, and then times a -3, because my b value is -3. And then I have a 6 times my a value, which is x squared, times my -3 squared. Then I have a 4 times my x times my -3, which is to the third. My board is going a little haywire over here in the corner. And then my 1, and then my b value to the fourth power. And then I go through and simplify. 1 times x to the fourth is x to the fourth. 4 times x cubed times -3 is -12x to the third. 6 times x squared times -3 squared. -3 squared is 9 times 6 is 54. So 54x squared. 4 times x times -3 to the third power. Well, -3 to the third is -27. Times 4 is -108. And that's an x. And then lastly, I have -3 to the fourth power. So that's going to give me a +81. So you see how I use that formula. Just plug everything in the way that I need to. And then that gives me my expansion. I don't have to go through and FOIL multiple times in order to get my answer. So for this one, my a value is going to be s squared. B value is 3. So I have the coefficient times a to the fifth. Because keep in mind, with this one, my n is now 5 because it's to the fifth power. So I'm going to be starting off my a at 5 and then counting down. Next coefficient, a to the fourth b. Next coefficient, a to the third b squared. Next coefficient, a squared b to the third. Next coefficient, a b to the fourth. And then our last coefficient, b to the fifth, because the a is now gone. So we would go through and plug in a and plug in b, and plug in your coefficients. So this is 1 times s squared to the fifth, and then 5 s squared to the fourth times 3. That does not look like a 4, so I will go through and try to fix that. There we go. And then my next coefficient, s squared to the third. The 3 is now squared. Next coefficient, s squared to the second. The 3 is cubed. Next coefficient, s squared to the first. The 3 is to the fourth. And then the last coefficient, I'm not using the s squared anymore because my a value is gone, but the 3 is then to the fifth power. And then we would go through and simplify that. So it's going to be s to the 10th plus 15s to the 8th, because s squared to the fourth would multiply exponents, so it's s to the 8th, plus 90 s to the 6th plus 270 s to the 4th plus 405 s squared, and then plus 243. So hopefully you can see with this one, there are no negatives because there were no negatives in the binomial. My exponents of s do go down by 2's because when you square, or if you have an s squared raised to different exponents, that will decrease by 2 each time. Eventually it does go down to 0. So it does look a little bit different than the regular binomials do. Please go back and rewatch anything that you aren't sure of in this video. Make sure you take down some notes because you will be having an assignment dealing with these same exact types of questions. And reach out to me if you have any problems.